Hi, Fatih.
Hi, Oliver. How are things?
Good, thanks. How are you?
Good. It's like one of the topics is the meeting time. Now it is 5 p.m. here, and the next meeting is supposed to be at 6 p.m., which makes me doubtful. Like it will be pretty late for us.
Yeah, I missed out the TOC meeting on Tuesday since I didn't realize that the
Yeah.
time moved. I was joining at 5 Europe time and was like, nobody in? Okay.
Yeah, it's like I updated the SIG meeting on public calendar, so it is like 4 p.m. UTC, but talk meeting stayed same, so it was like 1 hour earlier than the usual time.
Yeah, it's these 2 weeks of
Yeah.
different summer times, it's always a nightmare.
Yeah, I think Andrea was talking about not having meetings this period, like next year. Or October, was it like when will it take again? November, yeah, this thing. So we can perhaps skip that meeting if it falls in between this, or we fix the world. I don't know which one is easier. So let me share my screen. And thanks everyone for joining, and thank you, Dina, for joining. I was a bit afraid that we, because of this time zone thingy or daylight saving times, but now you are here. I am comfortable. So welcome. As usual, if everyone can put their names to the document on HackMD, that would be good. And I hope you can see my screen. And we can slowly start with the agenda, followed by action item review and few notes. And then, as we discussed during previous meetings and announced on mail lists, we have Dina with us today, giving us a short presentation on 4Keys project, followed up by an open discussion about how to collaborate, what kind of challenges they faced, and what kind of challenges we are working on addressing within Continuous Data Foundation under different groups and projects. And then last topic is a heads up on policy-driven CI/CD, or a reminder if the time allows. So let's start with the action item review. The first action item is starting to work on artifact metadata and bring the example from Ortelius. Do we have Steve with us? Not yet. So, but I remember seeing some updates to HackMD document. Let's check. Okay, yeah. So Steve made the updates. I will keep the action item open and confirm with him on Slack to see if he wants to close the action item or not. And then we do it accordingly. And the next action item was on me to send mail to CDF, SIG talk, and user mail lists about Dina's visit to this meeting. I did that. I sent mail to SIG Interoperability talk and end user mail lists. I also put a note on SIG best practice and SIG events Slack channels, because those groups are using Slack heavily. So I can close this action item. And the next action item is on Kara to help with Jenkins and cloud-based policy approach. Kara?
I have added to the HackMD doc. For Jenkins open source, it's relatively light, but there is interest actually for supporting Open Policy Agent, and in fact that might be put in place shortly. But for cloud-based plugin, there is this plugin. It is entirely it is moving forward, but there is only one rule in place right now to enforce timeouts. So it's more putting in place a plugin that will be extended further with more rules in the future.
Okay. Thanks, Kara. And it is like, I think we have a support Open Policy Agent. Spinnaker supports Open Policy Agent as well. So it's like Open Policy Agent seems to be the way the community is thinking of addressing policy. Yeah, this is like one of the things we attempt to do with this work, to identify the commonalities between different communities. So closing the action item. Thanks for adding the info, Kara. Okay. So I reached out to Cameron about Armory policy approach. And I also learned from Cameron that Spinnaker community started talking about policy topic as well. So, and he told me that he will try to find more about that, and we might see Open Policy Agent in Spinnaker community as well. And as someone noted on the document, Armory flavor of Spinnaker supports Open Policy Agent. So the community might go same direction as well. So I close this action item. And then the last action item was on Oliver to upload Project Piper presentation to the repository. And Oliver, I think you did that.
That's uploaded, yes.
Okay, thanks. So closing that. Good. I think we closed all action items, which is always great. So the next topic is daylight saving time changes check. Our meeting time is locked to 4 p.m. UTC, as you all know. And when I check the meeting time for our next meeting and following meetings until the next change, it will be 6 p.m. for Europe. And it will be 9 a.m. for Pacific, and similar 1 hour later for other time zones in North America as well. So the question here is, should we switch back to 3 p.m. UTC so we go back to regular time for all the time zones, like 8 a.m. Pacific, 5 p.m. Europe, and similar to others? Or should we stay on 4 p.m. UTC, which may be late for European participants?
Yeah, I think switching it makes sense. So it's effectively the same time as it was before.
Absolutely.
Yeah, and I agree.
Okay. So I think, Emil, I think you made similar thing in events. You switch 3 p.m. UTC
Yes.
for summer, 4 p.m. for winter. So
Yeah,
we follow
exactly.
your example. Okay. Okay. And then me and Tracy, can we update the calendar? Because I always get confused, like afraid of making mistakes, you know, to update.
That's why I gave you access, because I'm afraid of making mistakes.
So if two people make mistakes, then it is difficult for others to see who did the mistake. So
Okay. Yeah, sure. Happy to sync with you on that.
Okay. And reminders will be sent about this on the mail list as well. So we keep the good attendance to meetings. Good. And the next topic is from Christy, and Christy won't be with us today, as she noted here. So she opened up a pull request in glossary repository, if I'm not mistaken. Yes, adding initial definitions for continuous delivery terms. And this discussion, if you remember, started from interoperability white paper, and then we decided we can't fix this in interoperability white paper because it's out of its scope. And then it moved to another Google Doc, and then it moved to a new repository in CD Foundation on GitHub named Glossary, and Christy started adding definitions here. So if you could review the pull request and provide comments, that would be great. And the other thing she made was addition of the timeline, which is great. I liked it a lot because it gives you some historical context about how this continuous integration, continuous delivery deployment DevOps, when did they come out and who made that and so on. This is also a good reference. So please look at the repository and pull request and provide your comments. And the link is in the document. So before I pass the word and screen to Dina, anyone wants to bring up anything? Because we may use the rest of the meeting for discussion on 4 keys and our collaboration opportunities. Okay.
Actually, Fatih, I just had one slightly related one. Just as a follow-up from this discussion, we're also going to be having the end user forum discussion around measuring DevOps and the DORA metrics. So it will be Dina again with a couple of folks from our end user council, but this time taking the conversation to like a very public chat and discussion. So I'll drop that link in the chat. But yeah, this is just part of our trying to do this topic to death from various perspectives and trying to pull in as many people into the discussion as possible. And then we're hoping off the back of that with the end user council, we can do a nice write-up of where this topic's at in the industry and what we think the direction we should move forward on is, which in large part will be influenced by the discussion today as well.
Okay.
And I've had a few requests for recording, so just checking we're recording, which is good. Great.
Okay, so if you can put the date, I've seen this on Twitter, but I don't remember where was it now. So if you put the date and link, Tracy, that would be great.
Yeah, okay, I'll
Thank
go
you.
do that.
Okay, so then we are on to you, Dina. I can stop sharing and then please take it over.
Yeah, thank you. Thank you for having me. Let me get this working. And you can see my screen.
Yes.
Awesome. Okay. I'm here to talk about the 4 Keys project, and I'm going to give just a very brief background on DORA because I assume most of you are already familiar with it. You know, DORA is the DevOps research and assessment team inside Google, and through 6 years of research, they identified that there are 4 key metrics to measuring the performance of a software delivery team. And they can roughly be split up into 2 categories, speed and stability. And on the speed side, we have deployment frequency and lead time for change. And on the stability side, we have change fail rate and time to restore services. Now, a lot of people assume that, you know, if you are moving really fast, that you probably have really low stability numbers. But actually what we see is that the people who move really fast, who like have like multiple deployments a day, who you know, the lead time to change is, you know, hours, they have a way lower incident rates, and also it is much faster to restore them when they do happen. So that's the very brief background on DORA. And the research was done through surveys. You know, over 6 years, lots of different companies, lots of different industries, and they used, you know, academic, peer-reviewed methods, and it was really rigorous stuff. And now what we have on the Google Cloud DevOps website is this like quick check where you can like fill out the survey, and essentially it kind of asks you the questions for establishing the 4 key metrics. So it'll ask you like, how long does it take for a change to get into production, and how often do you have incidents and things like that. On the Pro, it's really quick and easy to use. So if somebody doesn't have a lot of resources and just like really wants to get a quick check on where they are and how they're comparing to their industry, it's a good place to start. However, it is susceptible to bias, very difficult to measure over time, and it's not automatic. So if you were trying to measure your performance over time because you are adapting a new change review system, or you're using some new CD tools and you think that this is going to help with your velocity, then you would have to just fill out the survey several times over time. And what we see is that people have survey fatigue, and it's also just really easy for people to ignore it. So that is why we built the 4 Keys project. First of all, it helps alleviate bias. And when I'm talking about bias, it's like things like recency bias, or also like just generally like in your work role, the kinds of things that you are exposed to. So like somebody who's managing servers is going to have a much different understanding of the health of the system than just the person who's writing features and pressing submit, pressing merge. And then, if there was an incident really recently, you might have like a very outsized understanding of your change failure rate just because of recency bias. So using systems data helps alleviate the bias. It also makes it easier to measure over time. So you can really see like how how the experiments that you're doing are actually affecting your metrics. And it exposes bottlenecks, which is another thing like the survey can't really do. So if your change fail rate is a week, if your lead time to change is a week, then the survey will just tell you, oh, you are like a medium high performer. But what it doesn't tell you is like how much of that time was spent before the code was peer reviewed, how much time did it sit in the system waiting to be merged in, and then how long was the actual rollout process. So sometimes we see things like it's really fast to get integrated in, but it just sits there for weeks before it gets pushed out. And the systems data helps expose where in that process things are slowing down. And yeah, it helps quantify experimental success. On the cons, it's a little more difficult to set up than just taking a survey. And there are storage and engineering costs. So this is the project. It is on GitHub, and that is our little bit.ly link, bit.ly/Dora-4keys. And this is the design. So the great thing is that we have all of the data that we need to calculate these metrics. The challenge is that it is in dozens of different systems that people use. Like even on one team, you use one thing for your version control, you use one thing to manage your rollouts, you use one thing to manage your incidents. And how do we take all of this data from all these different systems and join it together? Also, when we're designing an open source project, how do we account for the unknown data sources? I am familiar with a certain set of tools that people may use, but obviously there's more out there. And how do you build something that is flexible enough to be able to adapt to these sources that we don't know anything about? And the solution that we came up with was to create a very generalized pipeline that takes in events via webhooks and ingests them into BigQuery. So the known data sources are then mapped and parsed properly. And unknown sources, you can add another pub sub topic and your little data parser and then flow it down through the tables. Okay, so data mapping is an upfront cost. It is kind of like the crux of the issue. So what we do is we put everything into this raw events table, 4keys.eventsRaw, and think of it as a DevOps log. It should contain every event related to development, deployment, and incident management. So when in doubt, stream it into the table. And then from there are these scheduled downstream queries that create these dimensional tables for these kind of like distinct entities of changes, deployments, and incidents. Now, one of the reasons why we do it this way is because data definitions change over time. And especially if you're using third-party systems that you don't control, you want to be able to compare apples to apples over time. If you decide that you need to update your definition of a successful deployment, maybe before you were looking at all the deployments where traffic was at least 50% users, and now you want to drop down to 5%, you should be able to have all that data still in your raw events log so that you can just add a few where statements in the SQL query and then update it. And that way it'll apply your new definition to the things in the past as well. So then you can see, using this new definition, how you are tracking over time. So we'll get into the metrics now. The first one is deployment frequency, which is how often an organization successfully releases into production. This is the easiest one to collect and calculate because it just requires one table. And actually, all of the metrics require this one table, joined with other tables. So if you're using any kind of CI/CD system, you have all the data. You stream this information into this table and use it to calculate frequency. Now, one thing that we see, one common mistake, is that people will often confuse volume with frequency. So a very common thing is that somebody will look at, pardon me. Somebody will look at their deployments over the past month, and they'll say, oh, we had 30 deployments in the last month. So that comes out to an average of 1 a day. So we deploy daily. Yes. No, not exactly. Because those 30 deployments, maybe they just happened on 2 distinct days in the month. So then you're not deploying daily, you're deploying monthly. And therein lies the key difference between looking at your deployment volume and your deployment frequency. When we look at frequency, we want to count not the number of deployments that we have, but the number of days that had deployments. Okay, so next we have lead time to change, which is the amount of time it takes a commit to get into production. So you need 2 pieces of information: when the commit happened and when the deployment happened. So this means that for every deployment, we need to maintain a list of all the changes included in the deployment. And this is really easily done, like trivially done, if you're using CI/CD. Like if you're triggering your pushes to deployment, to production, from changes being merged into your repo. There's like a SHA, it maps back, you can unpack it, you can see like all the distinct commits that were in it, pull out those timestamps, and then your lead time to change. It gets a little bit more tricky when people use other deployment patterns, in which case it's really up to the developer to somehow maintain that list. But if you want to know your lead time to change, you need to be able to join your change timestamps to your deployment timestamps. So the dashboard puts the lead time into buckets defined by Dora research. You can see the little badge there on the side. So it's less than a day, less than a week, a month, a year. Less than a week is a medium performance. So in the 4Keys dashboard, we show that with a yellow badge. Next, we have the change fail rate, which is the percentage of deployments causing a failure in production. So in this case, the deployments is our denominator, and the incidence is the numerator. Ideally, we should be able to join these 2 tables together on the deployment ID. So in an ideal world, we would have, for every incident, like a root cause, like this incident came from this deployment. And then we can use that to calculate our change fail rate. This isn't always possible, in which case then you need to start being a little more loosey-goosey with the metric here, and then you end up looking at it and saying that we had 30 deployments this month and we had 1 incident. Now the problem there is that incident possibly was caused by a deployment that happened last month, maybe before you put these new tests in place and these new systems in place. And so then it's not actually a reflection of your performance this month, it's a reflection of your performance last month. But if you don't have a way to join these tables, then the best that you can do is to just time bound it and make the rate that way. So next we have time to restore, which is how long it takes an organization to recover from a failure in production. And again, we have deployments and incidents. And ideally, I use this word a lot, ideally, you can join these together so that you know when the incident was created, and then you know how long it took to fix it. Often this isn't possible. So then what we do is that we look at the time the incident was detected, like the time that somebody added it to the incident management system. And then it's actually at that point, it is more a measure of how quickly you were able to fix it once you identified it. The reason why that isn't ideal, the reason why that isn't what we're precisely going for, is because we want to consider how the user is experiencing this. So for all of these things, like we're talking about our deployment frequency and our lead time to change, it's all dependent on things going into production, because that is when the user starts to experience it. So if there was an incident that happened with a deployment that was started last week, but we didn't notice it until this week, and then once we notice it, we fix it in an hour, well, the user maybe was experiencing that the entire week. And so we should know that, because then what that tells us is that we maybe need a better reporting system. Like why wasn't the user able to communicate that to us? Or we need better health check system. Like we need something in there, and knowing the full span of that time, it exposes those bottlenecks. Okay, so this is the infrastructure. You have your events, the event handler, which is your webhook, and it sends the messages from the events, like the entire body, to a pub subtopic. Each pub subtopic is it's for just that source. So you would have like a GitHub pub subtopic, for instance, and then that goes to a very, very tiny little like Cloud Run instance, which does very, very small ETL. Basically, it'll like look at that big JSON body and it will say, here's the timestamp, this is what the source was, etc. And then it puts that into the BigQuery raw table, which has a field that has just the entire body of the event, because we don't want to lose any data because we're going to need it, because things happen and suddenly somebody asks a question or like a definition changes very slightly, and we just need all the data. And then from there we have our downstream tables, and then that feeds into the dashboard. So I'm going to skip the demo video. You can watch on YouTube. So this just shows how we run the setup script and how you can integrate it with some different version control systems and some different deployment systems. And then it shows the data going into BigQuery, and it shows the dashboard. Oops, no. So let's go to the dashboard. Okay, right here down the middle, these are the 4 key metrics as defined by the DORA research. And it puts it into the buckets from the DORA research. And this is the thing that is predictive of successful business outcomes, which is a stronger relationship than correlation. And those are things like profitability, and also job satisfaction. So your developers will be happier if these badges are green. Around the edge, what we've done is we've added some charts that show basically a daily running log of your performance. And the useful thing here is because it's kind of like an early warning system or early feedback. So if you have a new experiment that you think this new CD tool you're using is going to really improve your deployment frequency, then you would be able to see that pretty early in the chart in the upper left-hand corner, or the upper right-hand corner, and that would allow you to get a feel for like whether you're trending in the right direction. So because the buckets down the center are their 90-day aggregate view, and so it could take some time for that to flip over to the next level. So things we don't want people to do with the dashboard. We don't want people to like sick teams on Teams, because the product that you're working with has obviously different technical debt. And really like the reason to use this is to establish a baseline for your performance now so that you can perform on it. It's not for me to compete with, you know, my friends working over there. It's for me to compete with me. And that is why we want people to, you know, to use it to establish a baseline, and then to do some kind of, you know, experiment use, find the bottleneck, work on it, and then, you know, iterate and keep coming back to the dashboard to see how are these numbers trending. The next thing is the metrics. You know, it's a diagnostic tool. It is not the goal itself. Like the goal is not, let's have really great deployment frequency. The goal is being able to roll out features that your users want faster, more frequently. So I think that when people use the dashboard and set goals around it, they should really reflect the projects and the experiments that they're taking on to get closer to that actual end goal, and then you use the metrics to measure against, you know, again, as like a diagnostic tool. Okay, so here is the 4Keys project. If you go into the repo, you would run the setup.shell script to play with it. You can read more. We have a blog post up on the Google Cloud blog. We have a Slack channel if you want to come and chat with us. And that's it. That's all I've got to say. I hope I didn't talk too long. And I am very interested to hear your questions.
Thanks for that, Dina. I'll go first while everyone's warming up. Can you say a little about the integrations you've already done? So I know this Tecton, but maybe that's worth repeating, and all the other projects that you've currently done. Yeah, integrations basically. Yeah.
Okay. So the sources, the event sources that we've integrated with so far are GitHub, GitLab, Google Cloud Build, and Tecton. I think that's it. And, you know, obviously GitLab and GitHub, they can be the version control system, and they can also be your deployment system. And we have, up on the repo, we have a roadmap of all of the integrations that we want to do. And they are like Jenkins, TeamCity, Spinnaker, Jira, ServiceNow, PagerDuty, Bitbucket, GitHub Enterprise, and Git, which is G-I-T-E-A if you haven't heard of it. And also, which I'm gonna mention, since this ties in nicely to the question that Tracy put in the chat there, is I've also added Google Forms because incidents are hard to identify and classify. And obviously some people have really good incident management systems that allow you to identify a root cause, there's a subset of incidents that are not as hard to identify because you can, like in things like Stackdriver, you can automatically detect them, and then that bubbles up into your data, and then that's great. But not all incidents will cause like actual errors. Not all incidents will be possible to detect automatically. And so that is why I tend to shy away from doing that kind of approach. I ultimately, like, the simplest thing that you could do is just have a table with the deployment ID and like the incident, and like a Boolean, like true or false, was this an incident? And so that is why I added Google Forms. Like if you don't have, for people who don't have a more elegant incident management system, that's kind of like the bare bones. Like if you had a form where you answer just these few questions and put in the IDs, then you can ingest that form into your data. And yeah, it's, yeah, if you look if you look closely at the SQL scripts currently for incidents, it's just looking for like it's doing a regex, looking for some keywords to pull out the ID for the change that caused the incident. And that was just to show like, here's one way that you can do it. But there are better ways.
Okay, I go next then. About the tools or tools you collect data like GitHub, GitLab, Tekton, and like you mentioned also you have roadmap for others. Like how do you reach out to those communities directly, or how do you get these things in front of them? Like, okay, we are trying to do this thing, Forky trying to get the data out of the tools like Jenkins or like Spinnaker or Gerrit, for example, for software configuration manager, or Artifactory for artifact repository. Like, how do you find who to talk to, and how do you get these things in their attention?
It's really interesting. We very much have done it the other direction so far. It's been like users who have like filed issues on GitHub, basically saying I'm trying to use Jenkins, or it's like our customers, like some of like the big Google Cloud customers who happen to use this or that, and all the customer engineers who work with all the different companies, and basically have come back and let us know like these are the things they use. So these are kind of like the blockers for people to adopt this.
Okay, so it's like fixed by the community or Forky's users, kept in your repo perhaps, and like the upstream communities or the vendors of those tools may not know you did this thing and they change things, and then what your community did may be broken tomorrow, for example.
Yeah, it's true.
Because like we are talking about pretty similar things, like that's why this artifact meta or the metadata topic we were talking about during the action item review, like we are trying to collect such metadata like Git metadata or artifact metadata to see like how we can somehow, I don't want to say standardize, but somehow at least make it visible to start with, and then find some way to converge on some common way to use the metadata or get the metadata or consume such metadata. I think, like as we have been talking via mail as well, like this is a common thing both in broader interoperability context and in your context.
I mean, I think some kind of standardization would be great. My concern with the architecture of this was basically kind of like people have error budgets. Like I assumed that the sources could and probably would change their data models at some point. And I try to get the data into a persisted state as soon as possible, which is why there's not a lot of ETL that happens closer to the event source. Once it gets into PubSub, then I have confidence that even if the data mapping is no longer correct, then it'll still stay in PubSub and keep retrying until the mapping is resolved. So then the very tiny little ETL worker, which is looking for a field called X, Y, or Z because it's trying to pull out the timestamp, then if that breaks, then it won't return a successful message to PubSub. So PubSub will just keep trying until that's fixed, and then that would resolve. So we use more of like a defensive approach to just assuming that things would change and things would break. But it would be it would be great if we could get the community to more, to like kind of widely acknowledge that these are the pieces of information that are important that we're looking for. If we could even have like 4 keys fields, that would be pretty cool.
I have events questions, but I leave them to events SIG members who are here today. One last question about, like, again, you generally touched on SCM, like commit stuff and like deployment frequency. And the thing I want to ask, like this deployment frequency or lead time for changes, they also depend like how much time it takes to run your tests, for example, in your typical continuous integration, continuous delivery, and deployment pipelines. Like, do you have any, the test, how much time it takes to run tests, or how many test cases pass and fail, how regularly or how frequently they fail, is not in those like 4 keys, but they are hidden within those figures. If you have slow running tests, then your deployment frequency will suffer from that. You will not be able to deploy frequently, or you will not be able to push your changes to production as fast as you can because it takes a day to run your test. Like, any way to or have you put any thinking around like extending this approach to those things as well, like SCM systems, CI/CD, but the frameworks, test frameworks like test and JUnit, that type of stuff?
We want to keep the project very much rooted in the research from the DORA project. You're right, these are hidden. These are like hidden metrics that are under the hood, and there are a lot of them. The problem is like they're not the metrics that are indicative of or predictive of like the business outcomes and all the things that DORA has found, but they bubble up. And so that is when we're talking about things like identifying your bottlenecks and just working on the one bottleneck. The research talks about the theory of constraints, that that you basically, like, any work done anywhere that's not the bottleneck it's frankly, it's a waste of time, because it's your system isn't going to go any faster as long as the bottleneck is the bottleneck. And these kind of like lower level metrics that you're talking about, they're the things that help you drill down and understand where the bottleneck is. So yeah, if I were trying to improve my deployment frequency, well, I mean, first of all, if it was like weeks or months between my deployments, I probably wouldn't be looking at the tests first. I'd be looking at like, you know, why are we doing deployments on demand? But then, you know, as like those bottlenecks are removed, then yeah, you'd get down to a point where like, oh, well, we can't go any faster because the test takes a whole day to run. Then yeah, you would start looking at that. And then the question there is, why? You know, why does the test take so long to run? So is it just, you know, it could be like, maybe it's, you know, the architecture that you're working, that you're trying to like test this like really big thing. And so you have a lot of different tests about how these things fit together. Whereas, you know, if you maybe went to a more, you know, service-oriented or microservice architecture, maybe your test could be very small and distinct to the point. And then that would allow you to push those services independently without having to do like a very large test run. And so I'm not sure that, we would put those metrics into the dashboard, but I think that I do want to put a little bit more work into, or a lot more work into teaching people how to use the data. Because if you have all this stuff in your events raw table, then you can drill down, you can pull out these kind of lower level metrics that do help you pinpoint your efforts and expose the bottlenecks.
Thanks. The reason why I ask is like, it's always, people always like adding new test cases, and that gives you a trend, you know, it increases, and people don't tend to remove test case if they don't, you know, add any value. But yeah, it's like, yeah, this high level for keys give you where could be the bottleneck. If you see something is going in the wrong direction, you can drill down and see, okay, yeah, we really need to take care of our test frameworks, test case, and add more equipment or whatever. Yeah, okay, thanks.
Yeah, and that's like, you know, that's like the beautiful thing about data-driven decision making is once you have the numbers in front of you, yeah, you know.
Love to hear some input from folks who've got internal platforms about whether this looks useful or relevant. I don't know, maybe Ramin or Oliver. Any thoughts?
Yeah, it definitely looks interesting. And from our end, we're looking into the topic. What I understand here is that you need Google Cloud infrastructure in order to run it today, right?
Well, our setup script sets it all up on Google Cloud infrastructure. But if you look at the actual like code, and we have another user who is actually starting to pursue this, trying to like genericize the architecture even a little bit more. But like the event handler, the like little ETL workers, they're containers. They're just like containerized Flask apps. So you could run those anywhere. They make calls out to, you know, the Google PubSub API, but obviously you can use a different kind of PubSub if you wanted to. So that would just be like swapping out like that line in the event handler. And I think, you know, the big thing would be BigQuery. You could use a different, I mean, it's all SQL based, all of the, you know, the data, the calculations, the metric manipulation, like all like the heavy lifting, like ETL kind of stuff is all done in SQL. To make it easy to essentially like dig into the data and change definitions, so that, yeah, it's all in the table and all you have to do is like update a SQL script. You don't have to like deploy a new thing. So you could use a different SQL provider. I'm a big fan of BigQuery, and for something where you're just doing insertions, it's pretty good. And also, there's a little bit of, I'm not sure if all, the SQL providers allow you to do little JavaScript queries, or like, I think they all provide easy ways to parse JSON now. So like a lot of this depends on being able to go into that body, that event body that's in JSON, and to pull out the fields that you're interested in. So yeah, all the code's there. If you want to strip out the Google stuff, you are very welcome to do so. It's containers and it's a relational database.
Yeah, thanks. Is there maybe some idea to provide it natively to get it installed into any Kubernetes cluster?
I think that's a good idea. What we are like thinking about and considering is how much complexity does that add? Like when people like run the setup script, we want it to just be very fast and easy for people to do. But yeah, we're exploring. We are open to it, and we are exploring different ways to allow people to essentially choose the host that they want.
Okay, that would be great. Because it's especially, I think, looking into the European legislation with data privacy regulations, etc.
Mm-hmm.
Especially larger companies will likely have issues, right? Sending the data to a database sitting somewhere, and
Right.
there might be considerations to be taken there as well.
Yeah.
But thanks a lot for your presentation. Like it a lot.
Thank you. Yeah, if you wanted to fork it and, try to install it into like a Kubernetes cluster, like you said, be very open to seeing that fork, and then also possibly merging some of those changes back in.
Yeah, thanks a lot for the presentation. And me and Emil and Matthias, we are part of the events SIG. It's a newly formed interest group in the CDF. And I guess the work that we're trying to do is related to the 4 key projects in a way, in the sense that we're trying to create a standard for events generated by CI/CD platforms.
Okay.
And one of the goals is to allow these platforms to talk to each other. And I guess the other goal, at least from my point of view, is to allow platforms to like do monitoring, tracing, measuring of CI/CD platform across different systems. So to have like one single system, like with the project that you worked on, and being able to collect the same type of data from different platforms. And so I think that that's the link I see. One of the areas that we have not, I mean, we're just starting, and we talked a lot about code versioning systems and testing and deployment and so forth. I guess one of the areas that we have not touched too much upon yet is incident management. So we started considering a category about operations, but we have not discussed about it very much. So I think it would be interesting for me to understand what kind of sources you have for incidents and how do you relate them to the deployments. So is it just timestamp based, or do you have any way to relate those?
So yeah, so some incidents can be automatically detected, but it will never be all incidents. And so there needs to be a way for a human to like go in and like mark that some deployment caused some incident. The main example that we give in the Forkeys project is just like there's like a GitHub issue or a GitLab issue or something, and then somebody adds a label to it saying this one was an incident and it was related to this deployment. It's a difficult problem because it necessarily involves human input, which obviously is imperfect, because people will forget, people will make typos, and we can, there are things that we can do to try to like alleviate that a little bit. But honestly, don't have a great solution. We've looked at different incident management tools, and in order to do this mapping well, at least, then you have to have some kind of human input.
Okay.
Yeah.
Yeah. Okay, yeah, makes sense.
Yeah. Because like not all incidents are easily detectable. Sometimes you get like 500 errors, and you can detect those pretty easily. Other times what you get is just a degradation in service, like some things are going X% slower. Sometimes sometimes things technically work, but they give unexpected results, and that is also an incident. As long as it is like actively negatively impacting the user and what the user is trying to do, that is an incident. To do the metrics, you need to be able to, you should be able to do the metrics well. I will say, to do the metrics well, you should be able to map that incident to a deployment. If you can't do that, then the next best thing is just to use the timestamp that the incident was detected in whatever incident management system that you're using, and then that'll be part of your, that'll be the timestamp that you use to do a time-bound rate, and then also you'll use the detection timestamp to tell, and then the close timestamp in the incident management system to say like, oh, that was the time to restore. The problem is it's not true. But then I will also argue that it doesn't actually matter that it's not true if you are improving it. As long as you're improving it, there's room for improvement. It doesn't necessarily matter that it's not 100% accurate, because it is still a useful diagnostic tool. However, if it's hiding the fact that you have a month where users are experiencing pain and you haven't put it in your system and you haven't done anything about it, then that's where you have a problem. But for the most part, probably it's okay to just use the detection timestamp.
Yeah, makes sense. Yeah, I mean, there might be incidents that are not solved by deployments as well, I guess. Like, it's better to err on the getting more in than fewer.
Yeah. Yeah. The thing that I like to always say with these metrics and with the dashboard, these are diagnostic tools to help you pinpoint like where the pain actually is. And also, as long as you are consistent with your definitions and your measurement, then it's still useful. It's like a scale. Like my bathroom scale could be 10 pounds off. It doesn't matter as long as that is the scale that I keep using. Now, if I go to the gym and use a different scale, then suddenly I'm going to have information that conflicts really wildly, and then I get into trouble. But as long as I'm using the same tool to measure my progress, then these details that we're talking about are less important. Like we've solved at that point, we've solved like 90% of the problem. And then the rest of it is, if you get to a point where you are like a high performer and you want to find that other 10% of it, then yeah, you start digging down into these details and trying to figure out how you can improve this mapping, how you can get something that is more consistent and essentially a better representation of reality. And yeah, but for most people, like we're down here. We don't need to worry about the little details that help us, get that far once we get up to that level.
Okay, so sorry to interrupt. Thanks a lot for questions, and thanks for providing answers, Dina. So like what happened during the last meeting, we suddenly lost the meeting. So I want to thank everyone for joining the meeting today, and we can stay online and see if someone ends our meeting, but otherwise we meet again in 2 weeks, 1st of April, 3 p.m. UTC. And so, yeah, if anyone wants to stay, I don't know if Dina, you have time to stay on and continue conversation, we can stay, or if not, then again, thank you for joining the meeting and presenting 4 keys to us, and hopefully we find some opportunities to collaborate with you and your community, and hopefully you can join our future meetings as well.
Yeah.
So,
Thanks.
thank you. Thanks, everyone.
It's been great.
Dina, thank you so much
Thanks.
for your presentation. Can I ask you a question? Do you have time to?
Yeah.
Okay. I really noticed how you said these tools are or should be best used at this point for your own team. Both the team being measured should stay consistent, and then also the measurements used. So theoretically speaking, these would be very difficult at this stage to be able to use these sort of measurements to give a predictive like recommendation to a team, like, oh, you're deploying not enough times, teams at your size or at your workload are deploying more often, they have less incidents. That would be really, really not wise to think about doing those kind of recommendations at this point.
Yeah, I wouldn't recommend that, because it's kind of like it's missing the forest for the trees. It's at that point you look at it and you say, why are other teams deploying more frequently? And usually it has something to do with like a different capability that they have built up. And so then at that point, then the goal is, well, let's work on this capability. And if we identified this correctly, then we should start to see deployment frequency go up. But no, I've worked on teams as a data analyst, like operational teams as an analyst. And once you start using the metric as the goal, people will do all kinds of really strange things that you don't want them to do, just to try to optimize that number. So that is, staying away from that and focusing on like capabilities and experiments. It's a better way to drive that change. Otherwise you'll have people, just deploying the same image over and over again, or maybe they will change the definition of what a successful deployment is, so that going to staging is a successful deployment, which that is not, that doesn't count. So yeah, you focusing on the numbers does not usually end up well.
Great, thank you.
Okay, anyone else?
I just had a quick question about whether you looked into anything like on the Jenkins integration side yet. Like I know Jenkins is far from opinionated and has lots of different ways to do different things, but has there been any initial investigation into kind of an approach there or one path that would make sense?
No, it's on the roadmap. But I will say that Tecton is another thing that is not very prescriptive, and the fields that you get are basically the fields that you put in the YAML, and that's the beauty of just putting in the entire body, like the entire JSON into the table, so that the people who are running the workflow should know that they call their deployments this, or this means that. So there, with things like that are not prescriptive, there's an upfront cost, a data mapping cost that we can't do for you.
Makes sense.
Okay, so I look forward to your panel then. You put the date there, Tracy. I've seen it, 1st of March.
Yes.
So yeah, so that will be great. I think that we have participants from end user council as well, so it will be a great discussion, I am sure. Yeah. Okay then. Again, thank you, Dina, for joining. Thanks a lot, and let's see how we can help each other and move this thing forward, because like many things you summarized during your presentation and during Q&A, it's like we have a lot of similarities, like the challenges. Like I'm coming from an end user organization and we are talking about these things day to day, like when we want to introduce new tool or technology, like we always have the question, okay, how we can pull the data from this tool, because like we can't do that. We have to go and fix this thing ourselves, and then it delays things and it gets deprioritized, and or go and fix that thing because someone else comes up with something else, some other data from existing toolchain and so on. But yeah, we'll see. It's a difficult thing to deal with, but that's why we are here, I suppose. So we have to continue pushing.
Yeah.
So thank you and have a nice day, everyone, and talk to you in 2 weeks. So bye for now. Thank you.
Yeah.
Bye.
Yep.
Bye.